Good morning, everyone. Happy New Year. I'm Ashutosh Garg here from Furnace Improvements, uh, talking today about air preheating systems design. As you are aware, we are conducting this fire heater design training, and today we will be talking about air preheating systems. This is the 8th session of our design training webinars. The previous sessions are available on YouTube. They are also available on GoToWebinar site. So if you are interested, you can learn about those. If you have any questions on this webinar, please send it to me at my email, agard@heatflux.com. So why are we doing these webinars? Uh, when I started my career in 1974, the fire heater design was a closely guarded secret. Very few people knew about how to design fire heaters. I believe there were only 3 or 4 companies in the whole world, Foster Wheeler, Lummus, Petrochem, who were designing fire heaters. And I had my first experience, first engagement with fire heaters in an ammonia plant. We had 3 fire heaters. 2 of them were startup heaters, and then we had a big fire heater called steam methane reformer or steam naphtha reformer at that time. So I learned about fire heaters, and then I moved to other companies and I started designing fire heaters. So I realized over the period of time we need to spread the knowledge, let all our customers become aware of steps involved in fire heater design so that they can specify better fire heaters. They can understand the design issues related to fire heaters. And today we'll be covering a very important energy saving device called air preheater. In fact, air preheater is almost like a system by itself. So we'll be covering part of it today. So with that, let me start. I think most of you know me by now. I work for Furnace Improvements as a solution provider. Uh, I have more than 50 years experience now. I've been very fortunate to work on fire heater design for almost 45 years or so. I'm a chemical engineer by profession, and I passed out from IIT Kanpur. 1996, I started Furnace Improvements after working with different companies, and have been there since for the past 28 years. Uh, I believe most of you know about our company, Furnace Improvements, but we started in March of 1996. We have completed 28 years. 2005, we opened an office in India, engineering office, and today our main engineering office is in India, and the project office, sales office is in US. We have a contrarian approach to designs and operation, and we have always questioned the conventional wisdom. And out of that questioning, challenging the conventional wisdom, came out 3 patents. The first one was split flow technology. We have about 12 references of split flow, mostly in the catalytic reformer or platformer service, even though we have used now in other applications. And it's a very good technology for increasing capacity, reducing pressure drop across heaters. The second technology we came up with was inclined firing technology. And inclined firing technology is a very good, simple design for eliminating flame impingements, reducing tube metal temperatures, increasing the tube life. And we also have about 12 applications or 15 applications. It's so nice that all the new heaters which we supply comes built in with the inclined firing technology. And the third one is smart stack damper. This is the latest one about 5 years ago. Uh, we looked at why the fire heaters are not working as efficiently as they are supposed to be. And initially we were suspecting it is the operators or it is the quality, it's the damper workmanship, but later we realized that the design of the current stack dampers is deficient and cannot control the stack dampers, control the stack draft. So we came up with this smart stack damper and we have started installing it in our heaters and in other heaters. So just to give you a brief about how we work, as I said, we have a contrarian approach. We want to provide you with the unique value added solutions. And our mission is to improving the performance and efficiency of existing fire heaters. When I say fire heaters, we also include CO boilers. We have done some utility boilers. And our model is doctor-patient relationship. So we work directly with the owners and end users. Our motto is do it once, do it right, because we think it's the most economical way of executing projects. We try to make sure that our solutions are 200% accurate. That's how much safety margin we keep in our designs so that your money is not wasted. And as luck would have it, India is almost like 12 hours ahead, so we are working round the clock, and we are able to keep schedules and provide you with the best quality work. So challenges with your project: if you have a heater which is not working, which is inefficient, give us your worst heater and we will convert it into the best heater in your refinery, in your petrochemical plant. That's a challenge we are ready to accept, and that would be a good starting point with your company if we have not worked with it. That's how confident we are of our solutions. As far as heaters are concerned, we can work on all the refinery heaters, reformer heaters, crude heaters, hydro heaters, coker, hot oil, vacuum. As I said, we have worked on CO boilers. We are currently revamping a large CO boiler in Europe. We can do waste heat boilers. We have done the largest SCR unit on an 800 million BTU crude heater. We have done, I think, about 30 or 40 ultra low NOx burners project. So we have done the whole range, of heaters in the refineries. So we will be able to help you out. Uh, Most of our work is US based, and our largest customer is Phillips 66. Apart from that, we have worked repeatedly with Countrymark, Citco, Delec, Lyondale, all these clients. We have done work for HPCL in the past. We have also done work with other refiners in US and international. Uh, you may be wondering why I have to do this, but I have to do this to pay for the webinar time. I do want to thank my team in Noida. They have put up a wonderful presentation for you. We are going to be starting in a couple of minutes. They have worked very hard for about past 4 weeks now. I am only going to be presenting it. So please bear with me. We are a full service heater company. We can take care of process. We are mechanical, structural, CFD modeling, 3D modeling. We are the only heater company which does its own fabrication drawings, heater fabrication drawings. And because we do it our own, we are very fast in executing projects. We can give you a heater in 6 months if needed. We have been doing CFD modeling for almost 20 years now. Now we do combustion modeling, airflow distribution, fan suction, discharge ducts, ammonia injection grades, manifolds flow distribution. So we have done a lot of CFD modeling, and we have been using it to solve complicated combustion problems, flame impingement problems, demonstrating how good our inclined firing technology is, or how good our solutions are. I already talked to you about our three technologies. I'm not going to spend more time on this, but here is a depiction of an inclined firing technology. If installed in a new heater, it won't cost anything extra. That is how confident we are actually. So if you have been thinking of building a new heater, we can supply the new heater and it won't be any extra to get you this inclined firing technology. All right, so let's come to the air preheaters actually, and I have been fascinated with air preheaters. Just to give you my background, I started working with heaters when I was in KTI, and then I moved to Engineers India. And in India, the fuel cost has always been very high because we were not having crude production, or the energy cost was very high from the day one. So there was a lot of stress on efficiency improvement. In fact, I remember back in 70s, government of India gave a green light to Engineers India, which was almost the engineer who they were engineering all the refineries in the country, that any heater more than 10 million kilocalories should be fitted with an air preheating system. And most of those won't pay out in 3 years, but then they had a national payout. They said in the national interest, in the country's interest, as long as it pays out in 7 years, you can go ahead and do it. So while I was working in Engineers India, we installed a lot of air preheating systems. And then I came to US in 1990, and here it was the reverse. The gas prices were so low, nobody was interested in installing air preheating systems. In fact, there have been about 3 cases where client told us to remove the existing air preheating system. But again, the things have been changing, the energy price is going high. Now we are talking about greenhouse gas emissions. So efficiency improvement directly reduces the CO2 generation. So, and US government and governments in Europe are giving about $80 per ton of CO2 credit. So most of the projects, if you look at in US or Europe or outside, will start paying off in 3 years. So it's been a very interesting history. So most of the furnaces which are in natural draft mode have a stack temperature in the range of about 300 to 500 degrees centigrade, or 550 to 900 degree F. And this depends on the feed inlet temperature. Typically, feed inlet temperature is approximately around 250 to 300, 350 degrees centigrade. And for heat transfer, the flue gas temperature has to be higher than the feed inlet temperature, and that difference is known as approach. The typical approach in fired heaters depend about 100 to 250 degree F. There are many factors which decide this approach. We can go down to 50, or on case-to-case basis, but there are a lot of factors, and the most important one is an economical design. Every time we want to do this, we have to do it economically. So approach is around that. This is a graphical representation of the approach what we are talking about. You can see my team has done it. This is a fluid enters a convection section first, then it goes into the radiant section and comes out. These are the flames or burners providing the heat. This is the flue gas leaving through the stack, and the temperature difference between these two streams is known as approach. My team has also given a typical inlet temperature for different services, although these may vary depending on the preheat you have in your refineries. In the modern refineries, they extract more heat, so the inlet temperature may be a lot higher. But these are the numbers we have seen in a lot of heaters which we have revamped or designed in the past 30 years. So flue gas temperature varies about 300 to 500 degrees. That's typically that temperature. Now, you do want to improve the efficiency or maximize the efficiency, especially if the fuel cost is high. And I can narrate to you an incident I had about, I think, 10 years ago. We were doing a heater design for a company in South Korea. And the heater was, I think, only about 5 million BTUs or 1.25 million kilocalories. And the client wanted me to install air preheater on that heater, that small heater. I talked to the client. I said, no, it doesn't pay off. He says, don't worry, our fuel cost is almost like $16 to $17 per million BTU. That's how the high fuel cost they were paying actually. So I installed an air preheater or designed an air preheating system on that heater. So you want to have the maximum efficiency. And the maximum efficiency theoretically could be as high as 100%. Theoretically. But there are lots of constraints. We will talk about that. And the state of the art heaters will have about 90, 92. Some people stretch it to about 93%, but that's how high efficiency we can go, and we will talk about it. If you have a stack temperature of 500 degrees, the thermal efficiency is around 85. If it is 800 degrees, the efficiency is down for 78% or so. My team has done this stack temperature versus thermal efficiency. It does depend on the amount of excess O2 in the flue gases. We are giving you the good numbers over here, 1, 2, 3, 4, which is very, very tight operation, or we normally don't see such low excess oxygen in most of the fire heaters. That's a separate webinar I will do about controlling the excess O2. But the bottom line is, if you want to maximize the efficiency, we have to talk about stack temperature, reduce the stack temperature as much as possible. So the thumb rule is every 20 degree centigrade reduction in the flue gas temperature will improve the efficiency by about 1%. So if you reduce the flue gas temperature by 100 degrees centigrade, you will get about 5%. If you do it by 200 degrees centigrade, then you get about 10% efficiency. Most of that experience we have with the air preheaters, the average efficiency improvement, the most common number is about 10% in real life. That's how much efficiency improve. I mean, there have been cases where you can improve it by 20%, you can, but practically 10-11% is the number which air preheaters are generally, refineries, as I said, are targeting 90 to 92%, and the stack temperature we typically limit to about 150 to 200 degrees centigrade or 250 to 300 degree F. And the limitation here I'm giving it out is the sulfur content in the fuel. So we will talk a lot more about that in a little bit, but that's typically our objective here. So how can we get higher efficiency? There are two main ways. We can have an air preheating system or we can have a steam generation. Uh, the main difference between the two is in air preheating systems, the fuel consumption goes down. You get directly the benefit of reduced fuel gas consumption. In steam generation systems, the fuel consumption remains the same, but you generate steam for the free. You are getting steam production. You're not paying for it by the fuel consumption. You're not firing any extra fuel. So that is the difference. The fuel consumption remains the same before and after in steam generation, whereas in air preheating system, the fuel consumption goes down by about 10%. And both systems are equally popular, I would say. It depends on if your refinery is short on steam or long on steam. How desperately do they need the steam? That's what, you know. And we can do another webinar on steam generation, in fired heaters. We'll talk about it. So today we will focus the next 30 minutes on combustion air preheater. This is a picture from one of our projects we did several years ago. You can see the hot flue gas duct, hot air duct, combustion air preheater. This is a cast iron air preheater. So any heater where you have a flue gas temperature higher than 600 degree F or 315 degree C is a good candidate for air preheater installation. That's the thumb rule. I mean, we can do it even for 500 degrees, but industry kind of has a thumb rules. So 315 degrees, anything more than 315, we can improve at least by about 6 or 7% over here for it to pay out. So now let's come to the different types of air preheating systems. There are two types. One is dependent on how the flue gas flow is taking place in the fire heater. And there are two common modes of operation. One is the balanced draft and the other is the forced draft. And the second air preheating system classification is by how the heat transfer scheme is. So we have the most common one, which is direct air preheaters. The second type is indirect air preheaters, where we transfer the heat from the hot flue gases to a fluid, and that fluid transfers the heat to the combustion air. And the third one is an external heat source, like if you have a waste steam, you have waste hot oil, you want to preheat air, you can do that. So those are the different classifications. The most common air preheating system is the balanced draft. In balanced draft, you have both forced draft fan supplying the combustion air and induced draft fan removing the flue gases from the system. So that's typically the configuration. Here we have a fired heater. You can see a twin cell fired heater with the hot flue gases going to the air preheater, going down, and then we have an ID fan over here, and the ID fan is supplying the cold flue gases back to the stack. So that's the induced draft circuit. The forced draft circuit is an FD fan supplying the hot air to the, supplying the cold air to the air preheater. It gets heated up, and then with this hot air, it goes to the burners. So those are the distribution ducts. So that's typically the system, the most common one. This is a picture of an air preheater, plate type air preheater for a coker heater. You can see the FD fan over here. So air preheater installation is fairly complicated. It's not just one piece of equipment, If you see, we have the hot flue gases duct. This is the hot flue gas duct. Then we have the air preheater with the return ducts over here. And the flue gas goes into a hot hopper, cold flue gas. Then there's an ID fan. The ID fan discharges it, goes back to the cold duct and goes to the stack. This is the FD fan supplying the duct, supplying to the air preheater and going out. So, and then going out. This is the vertical cylindrical heater we are showing over here. So you can see it's a pretty complicated system, and a lot of times the cost of air preheater system could be 80% of the cost of the fired heater. So anytime you're installing air preheating system or air preheater, you have to do an economical analysis. Is my air preheater going to pay or is not going to pay out? Most of the companies in US are looking for 3 years payout. They are more aggressive. And if you just think about efficiency improvement at the current fuel oil prices, fuel gas prices, very few projects will pay out. They sometimes pay out when you club another benefit of air preheating system, which is capacity improvement. We are able to increase the capacity of the heater also at the same time. So if you club those two things, then a lot of times the air preheater installation may pay out. That's a schematic thing. We have already shown you almost a third time now. So this is the hot flue gas duct, and this is the cold flue gas duct, cold air duct, hot air duct. You can also have just forced draft air preheating system that for some heaters, you can go with a tubular air preheater on top of the convection section, getting rid of ID fan and simplifying the installation. Has been done, is not as efficient as the balanced draft, because once you have a balanced draft, there is no restriction on flue gas temperature. But when you have a tubular air preheater and you're using stack to generate the draft, you have a restriction on how low you can go down in the flue gas temperature. We have seen a number of tubular air preheaters, especially in India, where they have used this concept for up to about 15 or 20 million kilocalories, mostly for small heaters, but you can go even bigger heaters. So we were talking about different types of heaters now, which is the direct air preheater, where the flue gas directly transfers the heat to the incoming combustion air. As I said, that's the most common air preheating system. Here, is the picture of a air preheating system we revamped for a client in Texas. They had two heaters and they had a common uh, air preheating system. And this is a very unique installation. This heater used to have a rotary air preheater, and we replaced the rotary because rotary was kind of having problems with a plate type air preheater. And in order to minimize the duct, we installed this air preheater in an inclined fashion. One of the first air preheaters to be installed at an angle actually, and it's been working perfectly fine for about 15 years. Installed it against the manufacturer's recommendation, but it works. Indirect air preheaters. Indirect air preheaters is, as I said, involve an intermediate fluid. It could be the process fluid or it could be an hot oil. The hot oil absorbs the heat from the flue gas and then transfers it through combustion air. So, very unique system. Not very popular because a lot of times the cost is high and you have to have two air preheaters. You have to have a air preheater coil or convection coil for transferring the heat from flue gas to the fluid, and then you got to have another heat exchanger stream where that heat is transferred back to combustion air. This is a picture of a heater we built several years ago. This was a hot oil heater actually, and we took a small slipstream of hot oil, preheated the combustion air, and then used that cold fluid or flue gases to preheat that hot oil back to the same temperature and then mix it with the mainstream. Very neat concept and very compact layout. So we used the same concept recently about 6 years ago for building a air preheater in a similar design because the client was limited in the space. They did not have space for the flue gas ducting and ID fan. So we designed a very nice compact air preheater. I think we will show you very shortly. This is a indirect air preheater, but using a separate heat transfer medium. And you have a convection coil, and then you have a small compact coil for the combustion air. This is the heater which we built with an indirect air preheater. This has been in Louisiana. And you can see we installed the ID fans on the top. And the ID fans were installed because we also have an SCR system in the convection section apart from the air preheater. So we said, okay, let's put ID fans also. You can see the plot plan. This is a FD fan. Then we have a combustion air preheater where we are preheating the combustion air using the hot oil fluid, and then the hot air is going to the plenum. Very, very nice. This is about 30 million kilocalories heater working very nicely for the past 6 years. You can also have external air preheating systems where you have external, let's say you have a waste source of hot water, you have steam, you have hot oil, you have no use for that heat, low temperature heat. You can put a small air preheater, and conserve that heat. Not done very often, but you can always do it. That's a scheme. We are saying you can have any stream coming in, preheating the air, and then going out. So let's talk about the equipment as such, the direct air preheaters. And we have two types of air preheaters in the industry. The first one is known as regenerative air preheaters, and the second is recuperative air preheaters. So let's talk about the regenerative air preheaters. The regenerative air preheaters are very efficient, very compact air preheaters, and they are used very widely in power industry and utility boilers, large boilers. And there it is out of necessity because the volumes are such that if you go with a recuperative air preheater, the cost and the size will be tremendous. So because of those reasons, a rotary air preheater is the de facto standard in the power industry. And here the concept is very simple. There is a basically a mass of plates which keeps on rotating in a circle, and when that mass of plates comes in contact with the flue gases, it absorbs the heat, and as it is going into the air stream, it gives out the heat. So the metal plates get heated and then they go out the other way, they transfer the heat. So the concept is very simple, very efficient. The main components are heating surface elements which are contained in a basket. There is a rotor, there is a small electric drive or a pneumatic drive, bearings, casing. Uh, One of the designs which is very, very popular is called Lundstrom air preheater. I believe Babcock and Wilcox owns that company now. That's my belief. I'm not sure because these days the ownership of companies keeps on changing. Uh, so we use different types of materials: mild steel, cotton steels, enameled steels. If you want to go on the low side of the flue gas temperature, you use enamel steels. Uh, so normally to prevent the leakage of air into the flue gas, you provide seals. And the leakage can anywhere be between 5% to 10% to 20% to 30%. These are the advantages of rotary air preheater. Compact size, you can fire even high sulfur fuels. In fact, it is used in coal firing in all over the world for generating power actually. So it's susceptible to dirty flue gases. Maintainability is good, cost is very low, so that's the main driving factor. And corrosion of elements has no effect on leakage. Disadvantage is high rate of air leakage, corrosion, prone to fire. Uh, you limit it up to 950. I think 950 is a pretty high temperature. So it's a pretty popular design. It's not been very popular in refineries. Of course, in the old times, it was used, and I have a picture over here for a heater where a refinery was used. In fact, there is another large refinery group, I won't name them. They had rotary air preheaters as a standard for 50 years or maybe more actually, and now they are also changing it back to the direct air static air preheaters instead of rotary air preheaters. So it was a de facto standard for all their heater installations. I believe it was the cost which was driving it. But then they had issues, so they went back to the direct air preheaters. If you're looking for operation of a rotary air preheater, one of the most important element is to check the air leakage, check the oxygen content before the air preheater in the flue gas and after the air preheater in the flue gas. And that will tell you how much leakage is taking place, and whether it is time to repair or replace the seals. Let's talk about a tubular air preheater. Tubular air preheater is a simple tubular design, and that's typically used in forced draft uh, applications, small heaters. And you can see we can mount it on top of the convection section or make it as a part of the convection section. Flue gas flows from bottom to top. You know, so, and we have designed many of these tubular air preheaters, not very efficient, as I said, uh, because of the several limitations. But if you don't want to spend too much money, this is the way to go. Let's talk about the popular design now. And the reason I'm saying popular is, if you're familiar with the heater industry for the past 50 years or more, there has been a one big change or one major change which has taken place, and that is the change of fuel. In all the heat refineries in 70s, 60s, 70s, 80s, and in India up to, I would say, about 2000, heavy fuel was used as a fuel, heavy fuel oil was used, or liquid fuel was used in almost all the furnaces. Bottom of barrel, whatever is cannot be sold, cannot be refined, could be fired actually. And all those gunk or heavy fuel would have tons of sulfur. So that was a de facto fuel. And now, because of pollution reasons, because of so many other things, we have moved to fuel gas firing, which is much, much easier to burn. It's a difference of day and night. Fuel oil firing, I have had experience when I worked in Engineers India for 8 years and in KTI for 6 years. But now, in the last 30 years, we have had only 2 installations. In fact, we are supplying a heater, crude heater, to a company where they are still firing fuel, but very rare, you know. So the reason I'm mentioning is the plate type air preheater was not a suitable air preheater for high sulfur fuels. But if you are firing gas fuels with 100 ppm sulfur or 10 ppm H2S, this is the de facto choice because it's very economical. So the concept here is very simple. It consists of parallel plates with spacers. Flue gas flows on one side, the combustion air flows on other side. And it's a very compact design. You can make the flue plates corrugated or try to improve the heat transfer. This is a So flue gas flowing from top to bottom, air going cross flow, very simple design, compact construction, lightweight, no leakage, easy maintenance, and we can have wide varieties of configurations. Here is you can see the hot gas flow. This is the cold gas or combustion air flow, and you can see the spacers, pretty straightforward design actually. The material of construction is typically carbon steel, stainless steel sometimes for high temperature, cotton, enamel steel, Inconel aluminum. These are some erection pictures. You can see very compact. As I said, the disadvantage of this is not suitable for fuels with high sulfur content. We can make it suitable actually, but it involves other techniques. So most of the time we don't use it with oil fuels. With oil fuels, a de facto choice is a very rugged air preheater which has seen very good days in the past is cast iron air preheater. Uh, it was so popular that it was known by its brand name Deca. The company in Belgium, now it is known as Bicast, has been manufacturing it, I believe, for about 75 years now. And if you're firing oil, use this type of air preheater. It has cast iron tubes with fins on both the sides. You can see it. Flue gas flows vertically down, combustion air flows horizontally, cross flow. And now they have different types of cast tubes to take care of the tube metal temperature issue. This is one installation, one tube cross section I'm showing over here. This is the picture of an actual cast iron air preheater. This is, as I said, from Bicast. We have this sketch. Flue gas flowing vertically down, inside combustion air flowing horizontal. This is a design of a cast iron air preheater with three types of tubes. We have the conventional tubes, which they call it HT tubes. Then they have the LT tubes where there is no fins on the flue gas combustion air side, but they have fins on the flue gas side. And then they have the glass tubes, and they are able to go down to 120 degrees centigrade. It does require a water washing. Air is going and then getting preheated. Just a sketch. That's a air side. You can see that we have opened it for inspection, and you can see the air side passages. So a very effective air preheater design. This is the glass tubes. Not very popular. Glass is a very fragile material. They make it out of borosilicates, but refinery operation is very rugged operation. So these glass tubes, in my opinion, don't last very long. I have tried always to stay away from glass tubes in my designs, but I just want to let you know that borosilicate glass iron air preheater has been used in many applications. So as compared to rotary, there has been a very low leakage in air preheaters. Cold end blocks, of course, can be replaced in both the designs. Uh, these are more expensive. They require a lot more space. And industry, in fire heater industry, in the refining industry, we have been using static plate timers. So when you talk about air preheater sizing, there are several factors. Heat duty, that is one factor. Then the pressure drop on air and flue gas side. And third thing is the air leakage, depending on if you are having a static or a rotary air preheater you may have. So I have an example over here to show you. This is an actual case study, I believe. 91 million BTU heater. I think it's a crude heater. Inlet temperature is 572. Uh, Natural draft mode, the firing rate is about 110 million BTU. The flue gas temperature uh, leaving the convection is very low, 626. Ambient temperature 60 degrees. Efficiency is 82.7. And client said, hey, let's go get up to 92 actually. So very good application. Client didn't want steam generation, so we added an air preheating system. We cooled the flue gases to about 300 degrees, about 150 degrees centigrade. Combustion air gets changed from 60 to 532. And we were able to increase the efficiency almost to the extent of about 93%, 94%. I don't know exactly, but I think these are calculations done by my team, so I will believe them. They have done the energy balance over here. Total heat input is equal to heat absorbed plus heat loss. Heat input is fuel, air, fuel sensible, depending on atomizing media and type. Heat absorbed is the process fluid and then the total heat losses. This is a graphical representation of the same thing. So from the fuel side, we are firing about 97 with an air preheater. Combustion air heat duty goes up because now the temperature is 532, so about 10%, about 10.76. Fuel is zero, atomizing media is zero. Radiation loss, we have taken about 2.5%. Can be reduced also. Stack loss is about 14.84, that is before the heat is recovered. So you can see this is the fuel firing, this is the air this thing. Total heat input is 107, heat absorbed is also 107. So they are able to do the balance. This is they are showing the air preheater configuration here. They have done the calculations of the air preheater here. Flue gas temperature, flue gas exit, enthalpy. With simple calculations, I think all of you who are chemical engineers can do it, or there are several computer programs, they can do it by your side. This is just showing you different elements of air preheater. If you want, we can add steam air preheater to avoid corrosion, to raise the dew point metal temperature. So that can be done. This is a cast iron air preheater they have used. Then we have some simple guidelines for sizing of combustion air duct and cold air duct. Before I forget, I want to give you a reference of an excellent guide. Uh, I believe all of you have heard of API, American Petroleum Institute. I've been a member of API for almost 30 years now. And we meet twice a year to talk about fire heaters, air preheating systems, so many other things. And we have developed specifications, Uh, several years ago, API developed a specification for air preheating systems. Previous to that, there was no guide available as to how to design or specify air preheating systems. So the industry includes end users, engineering companies, vendors. We all met together, I believe, for about 5 or 6 years at least to develop this air preheater specifications. It was known as API 533, and later that API 533 got merged into API 560. The reason for that was mostly commercial, because API 560 sells very well, API 530 was not selling, so they just merged it. And now we have a very good API 560 which talks about heaters, air preheating systems, and these documents are c- continuously edited and improved. So it's a living document. If you can get hold of API 560 standard, read it thoroughly. That will give you a lot of information, tons of information on air preheaters, fired heaters, what are the pros and cons of each type of air preheaters, how to calculate ducting losses, what should be the velocities, what should be. So all those things could be a good primer for you, if you're in the industry. API learning, reading API 560, I call it a fired heater Bible, will be one of the good ways for you to go. And we have done this 50 feet per second velocity sizing for the cold air duct, hot air duct. Forced draft fan is basically simple pressure losses. Induced draft fan, the same thing. So combustion air duct, this is showing for our indirect air preheater, showing an air preheater, FD fan, cold air stack. So this is a 3D model developed on, and this shows the inclined burners. If you are looking at, I can show you the inclined burners. Air preheaters. Flue gas duct, we already talked about flue gas duct and cold air duct. Flue gas duct, we normally provide about 4 inches of castable lining. Cold air duct is typically about 2 inches. That's standard. Uh, I think I will stop here. Thank you very much. I apologize I could not cover the cold and corrosion. We will have a part 2 of this air preheating system design webinar shortly, where we will cover a lot more about cold and corrosion. We are out of time. Thank you all for participating in webinars. Send me your feedback if you want me to cover any topic. I'd be more than happy to put a webinar, and spread the knowledge. Hopefully, I believe all of you enjoyed. And if you have any questions, you can send me an email, or you can, okay, I see 2 questions. I have 2 questions. Due to presence of VOC content in the flue gases, can air preheater be damaged or punctured? No, normally we don't get VOCs in the flue gases. And if you are having VOCs or CO, that means there is a serious problem in your combustion. So that's what I would say. The second problem is, does plate type air preheater is prone to leakage? No, plate type air preheater is not prone to leakage. A plate type air preheater is very, very good design. If it is leaking, that means there is a cold end corrosion. There is a dew point corrosion taking place, and that is what is kind of leaking. Any other question we have? If anybody wants to send me any other question, more than welcome. And I hope you enjoyed our webinar. Give me your feedback, what we can improve. Thank you all. Bye.